Sig figs are a way of measuring the accuracy of and precision of a problem. You can't have exact results with inexact data. There are three main rules to sig figs and how you write sig figs and go about a problem. You have all non-zero numbers are significant, alright? Which means, 1, 2, 3, 4, 5, 6, 7, 8, 9, all these numbers are significant numbers anywhere in the problem. So if you have the number 2.3, there's two significant figures, because they're all non-zero numbers. For zeros, it's different, because they can be either significant or insignificant. They are insignificant if they're before any significant figure in a number. So an example would be like 0.005. In this case, none of these three zeros are significant because they are not after a certain significant figure. They're before, which makes so this has one significant figure because it is the only non-zero number and is significant. But if you want to but it is possible to have a significant zero in a problem. An example would be of a significant figure is if it's in between two significant figures, or if it's a zero after a decimal. So an example of this would be 305. In this case, 0 is a significant figure because it is in between two other significant figures. Also, if you have 3005, both of these are significant figures. They're locked in, or in between two other significant figures. When you have any zero after a decimal that also is after a significant figure, it shows that it is also significant, such as 3.00. This would show that the answer is not 3, which could be anywhere from 2.6 to 3.4, but 3.0 shows that it is between 3.00 4 and 2.996. So it shows a much smaller range of numbers that can be in between. Now, an example of a sig fig problem would be 3.409 times 2.64 plus 6.5. In this case, every single number here has its own amount of significant figures. This number right here, because it has a 0 in between two significant figures and it's behind a decimal, it has 4 significant figures. Right here, all non-zero numbers are significant. So this has 3 significant figures. This one has 2 significant figures. The rules for addition are that when you have adding two numbers or subtracting two numbers, the amount of decimal points behind the number is how you decide how much to round to or how much significant figures it should have. So in this case, when you add 2.64 and 6.5, you get 9.14. But since this only has 2 significant figures and 1 behind the decimal, this one needs to have 2 significant figures and 1 behind the decimal. So in this case, you want to stop to here. But you don't want to round before you're done with the entire problem because that could give inexact data. Now, once you finish what's inside the parentheses, you go to the outside and you multiply 3.409 times 9.14. Now, this has 4 significant figures. This has 2 significant figures. Because remember, we have, although this is a 3 significant number, we have to remember that we're going to have to round it later to 2 because of what we did inside the parentheses. So when you multiply these two numbers, you receive a number along the lines of 31.15526. Now, this number contains many more significant figures than 2. Now, because 2 is the lesser number, you always want to go by the most inexact data. So, because we have 2 significant figures and 4 significant figures, we want to round this number to 2 significant figures. To do that, you check you have 2 significant figures, but we have to round it compared to depending on what's after it. So this number right here, 1 is much closer to 0 than it is to 10.
So then you just round down. So your final answer will be 31.